explaining you something about the Spanish context that's rather singular. It's not so usual. In Spain, this is the consumption, energy consumption in building in Spain, official data about it. You know? And what you see is that the average in Spain is about more or less Madrid, is about 240 kilowatts hour per square meter per year. This is absolutely huge, enormous and ridiculous in a country where a Mediterranean continental climate offers so many opportunities of energy efficiency. We have hot in summer, we have cold in winter, we have thermal amplitude between day and night, and that happens in 2/3 of, almost 3/4 of our geography. And then we have the coastal areas where climate is sweet and nice, and you don't have many needs of artificial climate if you use with certain amount of grey matter bioclimatic principles in building. No? And this is the scope. If only our buildings should comply with actual regulations, they should expend an average of 120. If they should our buildings be more or less efficient, they should be between 120 and 50 kilowatts hour per square meter. This is absolutely possible in Spain. It's not complicated. It's not a matter of extreme technology. It's something absolutely affordable. No? But the question is that Spain is clearly a poor country in Europe. We are in the group of the poor countries in Europe. But at the meantime, we are expending and throwing our resources and using energy as waste material and expending a lot of money in energy. So thus, this is a big opportunity for us. All this panorama of energy waste is the opportunity of savings, is the opportunity of financing the actions in energy efficiency in cities, in buildings, in industry. This is the scope of our work. We are lucky because Spain is never the peak, is never the vertex, is never the country that draws the chariot. We are always back. We are never ahead. And we are following the new addresses of the European community that lead to new performance-oriented models and to forget the prescriptive models we have always used in Spain. In Spain we are used, architects, engineers, everybody is used, users, to regulations that say you have to put this isolation, you have to put these windows, you have to use this machine, but that never ask for performance. Never ask for performance. Absolutely prescriptive regulations, never performance-oriented. But this is changing, happily. And this leads to, well, you have to do whatever you can. You have to take advantage of all the opportunities you have, and you have to obtain results. That's what we like of this model. ENERES, our company, is a company that comes from the joining the forces of several agents that have been building, designing low-impact architecture, and also from technological partners, people from Europe, from Austria, from Switzerland, that know very well, have a long time of experience in the recovery of energy from means like the ground, like wastewater, or like water nets. No? And we have joined forces to give integral services oriented to energy performance and to efficiency, let's say, to the improvement of performance of buildings and cities and the reduction of impact, not only energy consumption, but impact in general terms on climate, on health, on resources in buildings, cities and industry. ENERES is a well-known company that leads in the world the field of thermoactive constructions and geothermal exchange through building structures. CASAC is the company that began to develop in the 70s the extraction and recovery of energy from the wastewater nets, urban nets. And recent engineer that's in Bern in Switzerland is a company that has been very much specialized in the energy recovery in water nets. And energy from urban infrastructure is a source, like energy from the climate and from the external mean, is one of the main sources that we take advantage of to cover the demand of our low consumption buildings. Our services, in fact, are oriented to give this kind of comprehensive services for energy efficiency in building and urban planning. And we do it doing three things that seem very simple, but in fact are complex. Not complicated, but complex, as things are in nature, complexity. We reduce energy demands to the minimum in buildings. We find the lowest consumption solution to the building energy requirement, and then we implement operation and maintenance plan on buildings. Let's say that the first factor, reducing energy demands, requires the use of all the bioclimatical resources to the form, shape, and the evolution in the behavior of buildings, and taking advantage of all these local resources we have. Finding the lowest consumption solution to cover the building's energy requirement leads us to renewable energies and to strategies that mix different sources of energy and different ways of using and configuring the building. And implementing efficient operation and maintenance plan means that we are introducing in the behavior of building the concept of building that behaves, that changes its configuration regarding efficiency strategies during lifetime, and that adapts constantly to the optimum scenario of efficiency through control, through interaction with people. Buildings have to be implemented with equipment to be governed. Buildings they don't have to be intelligent themselves. They have to be governed by people. People government of building. Cybernetics, the relationship between buildings and people, is the way you can perfection behavior in buildings and have efficient operation and maintenance during lifetime. And this is very important for us, this part of intelligence. So our company is oriented mostly to performing all the tasks that are necessary to achieve energy efficiency and efficiency energy management. Our experience is that as architects, we never arrived to the final point of efficiency. As builders, we never arrive to the final point of efficiency, because efficiency is mostly obtained through a project, by construction, by mostly in management. And management is being within the building during lifetime and observing and correcting and adapting and perfecting its behavior regarding to the mean. We work in all the fields. In Spain, it is not a country intense and big enough to be specialized. We work in all the fields and scales. We work in urban development, in factories, in industrial buildings. We work for government agencies, for the state, and we work also for private and private institutions. We also work as consultants in terms of regulations, in terms of for private real estate companies and for quantity surveyors and designers, architects and engineers. Well, we are investing very much of our revenues in research. We cooperate with universities, and we are leading several research projects in the Polytechnic University of Madrid. We participate actively as professors in at least 4 masters in energy efficiency in Spain. So we are very active also in the transmission of our experiences. Our model regarding buildings is a model oriented to low exergy demand on buildings. let's say, we try to make that every unit that gets into of energy that gets into the building has to develop the maximum of utility and the minimum of entropy. We try to reduce the residual part of energy, working in the direction of obtaining efficiency through energy demand reduction and the improvement of quality. And we begin always, and then after we have reduced the demand of buildings, we apply only at last efficiency through technological improvement. So we begin with the envelope in a climate so generous as the climate we have in Spain, the correct design and conception of the envelope as an exchange device and as an exchange basic element of the building to obtain free of charge a lot of things from the climate and from the ground, energy and water and light and air. Afterwards, we work with the means of energy storage, transformation and transfer, let's say the climatic devices that regulate the absorption and the transmission of heat to people within the buildings. We are very much oriented to interaction between people and the external means through buildings. For us, buildings are a means of transmission of things from people to the external climate. And then we finally work on energy supply, energy transformation, on renewable energy from the recovery of every residual unit of energy that is produced and the reinjection of this energy as a primary supply resource in the building. And all of this should be, because all of this is object of a changing relation between changing users, changing climate, and a building that has to change to adapt to all these changes, of the collection of data, the generation of information, the programming of certain automatic attitudes of our buildings, the definition of strategies of efficiency that change within time and in the life cycle, operation oriented to efficiency, and maintenance oriented to efficiency in buildings. And this is our, more or less, very resume the scope of our work that resumes the three lines. But we also believe very much in the financing of efficiency through the energy that's spared and through the quality that's obtained. Both factors can finance energy efficiency, even though in Spain we don't return the big, you see in this graphic, in Spain we only return economically the individual amount that we generate with energy efficiency building. If we reduce the impact in terms of global impact, European, national, regional and municipal and sectorial impact that an efficiency has, in all these areas we have many factors that are affected by the lack of efficiency in building. Every time that we make a building efficient, we should return all this money. But in fact we only return 35%. That's the amount that we return with the energy that's not spent and with our particular benefit. You know, the real estate market has begun to very much evaluate the impact in terms of improvement of market value of energy efficiency and of that in buildings. That's not only the reduction of energy. In fact, for the real estate market, the reduction of energy cost is the less important factor of energy efficiency. In fact, for them, the cost of energy is less than a tenth of the cost of wages of the people that works in a building. So for them, this improvement is not significant. What's significant for them is that energy efficiency draws quality for the environment, draws better conditions for workers, draws better companies with higher wages, less hours lost by workers, less illness, and for them energy efficiency through this formula has a lot of implications in the rise of value of buildings, and this should be also be contemplated by us, that we are working as much as for energy consumption reduction, we are working for the improvement of the life and work conditions of users of our buildings. And there are people that translates this in money. This is one example of one of the things we have done recently in Portugal. We work very much not only in the rehabilitation of buildings, but also in the rehabilitation of projects. And this was a project conceived in Portugal, also in Aveiro, in northern Portugal, an area absolutely fantastic from the point of view of bioclimatism, sun, heat, cold, we have everything to combine and to mix and to transfer and to store and to manage. But then the building was absolutely symmetric. It was a nice form, like a bridge over a river path, no, without water, but at night with with a lot of cold air, and then a sunny place with enormous amount of sun resources. Well, let's say that following our simple schema, we began with bioclimatism, and this building had an enormous possibility to transform itself in a machine to capture sun and light, and air, and draw it through the building to cool the building for free, put the sun inside to make the building healthy and to heat it. And all this had to be done, taking into account that the building had to be designed to take advantage of these possibilities. In fact, the building changed it completely. It lost its symmetry. It was oriented north-south, and it was, as you saw, completely symmetrical. So the building changed absolutely its internal configuration. Walking area and distribution areas were at the north, and all the lively spaces were illuminated and ventilated through skylights, because the cover of the building, the roof of the building, was the main surface to interact with the men. And then to fix this, to fix heat and to fix cold, we needed mass. And the building was conceived without mass. Very light, like a bridge, without mass. And mass interacts with air and interacts with sun to concentrate, store, and let us manage energy. So we introduce mass in the floor of the building that's in contact with every user, and that gives the building an equilibrated amount of radiation working with the temperature of air to obtain the best operative temperature and the best operative conditions. No? So that changed completely the building, and then in this building that gave also the possibility to use this mass to concentrate the system, to embed the system of climate, because we transform this slab in a thermoactive slab that cools and heats the building. And then we took also advantage that this building was founded on a very compact and conductive ground that was fantastic for geothermal exchange. So finally we used all the means of sun, air, geometry, topography, ground to interact with the building, and we made a building that was provided with all these means of interaction. So you see the pictures of what the building was built, finished to be in its south face, that's that one. In its north face, that's only open to draw air through it in summer nights and in spring nights also, and to allow ventilation, lightening of circulation areas. Well, this is the configuration. It was a new building, but we work very much also very much in rehabilitation, in the recovery of old buildings, and the providing these old buildings a new life cycle. Yeah.
When did you come into the process of this project? The last one you said it was very symmetrical, and then
Yes,
You mean when they were going to build it, or?
No, when we were asked, there was the first layout of the building was made, what we call an anteproyecto, is before, avant-projet en français, is the previous sketch. It's more than a sketch, but less than a basic project. No, it was at the beginning. It was a good idea. Good ideas were there, and we were integrated not only as consultants, but also as architects. So we had the opportunity to interact with an architectural department of the University of Aveiro and transform the building. Because for us, the efficiency is an architectural matter. The building is not separated in different components that are then aggregated, but you see shape and architecture leads form, space, and interaction with the mean. And then construction, energy, air and water movement, everything is integrated. No? So finally for us it was good to get into the process at the beginning. But if I can tell you that many other times we get into the process when the buildings are completely, fully designed, and then they are going to be built, and they have been assigned with a closed price to a builder. And then they are, owners are aware that things are not going to work properly, that they cannot lose this opportunity, and they ask you to get into a process that's economically and technically closed, and you have to act within these restrictions and modify the building without attacking architecture, and you have to modify the building without rising the cost. And this can be done because you know, the point is that opportunities are out there, and if you take advantage of them, you reduce so much the amount of technology that the reduction on the cost of technology can equilibrate the balance of cost with the investments you make for bioclimatism, for instance. And then this is the case of our rehabilitation, and this is one of those cases we have just commented. When we were called, the project was finished, and it was a full air-to-air project with conventional chiller systems that worked for a building that was devoted to children. And children are users with much more exigence in terms of air quality and in terms of heat transmission than adults are. In fact, they breathe twice the amount of air that we breathe per kilogram, and they have twice the surface of skin we have per kilogram, because they are metabolisms that are absolutely accelerated, and they interact with the mean at double speed with it. And so then you have to be absolutely careful with the quality of air and the way heat is transmitted to those children. And then here again, and I resume very much because this project was very interesting in its first steps, we took the decision that transmission of heat will be radiant, once again, using the horizontal surfaces where children are very much closer than we are, and then geothermal exchange should be also used to improve the quality of air, to assure a good renovation and freshness of air without consuming energy. And in this building, we had to renovate it was an old industrial building that was protected, so its envelope should not be modified. And then here, for the use of this building as a children's theater, it was transformed to be a children's theater in Madrid. They needed an amount of 24,000 cubic meters of air every hour that have to be replaced, and that was the main vector of energy consumption in the building. So first, we had this building that's preserved but excavated 8 meters to make the theater within the building, and the project had slabs, 30 centimeters concrete slabs for a structure with long spans of pillars, and this is an enormous mass, structural mass, that could be directly used to stock, to store, to absorb and to transmit heat to the air and the users. No? So we connected the ground, we drilled 30 6 exchangers, vertical exchangers of 200 meters depth, to use the ground as a storage mass between winter and summer, and then we connected this to all the concrete slabs of the building to use this as a thermoactive geothermal climate system, no, for cooling and heating the building. And then we needed to solve the main point of this and the main opportunity of this project, that was the treatment of the renewable air, the fresh air that we were introducing for these children to breathe. No? So finally we decided to make what is now the biggest ground-to-air exchanger that's built in Europe in a rehabilitation project. It's about 3,000 meters long in 2 symmetric modules, and this allows us to pre-treat these 24,000 square meters, cubic meters of fresh air per hour that the building needs to assure quality, environmental quality. You know? And in terms of, and you see here the works, what you see in yellow is all the net of pipes, 25 centimeter pipes, for the air treatment, pre-treatment. You know, in Spain, in Madrid, when you put air at 35 degrees in a circuit that has different branches of 100 meters, when the air goes out and circulates at 8 meter depth at 2 meters per second speed, and when it leaves, it has lost 7 to 12 degrees. So this is pre-cooling that then goes to the heat recovery system of the expulsion of air and recovers a little more amount of energy. And when you put the air into the building, you have wasted almost zero in cooling the air, and you only have wasted energy in impulsing the air through the exchanger. No? And this is a very important resource, because through this conception, that's bioclimatism, heat transmission and air treatment, we reduced the charges of the building, the energy demand, from this previous more than 500 kilowatts to 160 kilowatts demand, directly, only through the use of these simple, logical, bioclimatically related devices in the building, using mass that the building already had, and giving mass, structural mass, also an energy sense, an energy use, and mixing all these concepts, taking very much into account the children. This is the finished building. Finally, it was a building that had previously an enormous machinery room over this. This is the part of the scenario, no? And over it, it was supposed to have enormous machinery room for chillers, air conditioning, and all this that has fully disappeared, as has disappeared all the internal piping for the distribution of cold and hot air, and all of this, because everything is now integrated within the mass of the building. This is another case of rehabilitation in Madrid. This is a palace that was a French-style palace built in the 20s in the center of Madrid, the barrio de Chamberí. And here, the point was that this building was going to be reused by the Justice Ministry of Spain to have a very restricted and securized area for fiscals. No? And the building was fully protected. You cannot touch the envelope of the building. In fact, you have to rebuild things that have already disappeared. And car parking was required, was mandatory, because all these people have a security regime of protection enormous with special cars and all this. The parking that could fit in this protected building was a robotic parking and fully automatic parking that goes 30 meters depth. And the opportunity of building with a 30 meters depth is clearly the opportunity of exchanging with the ground energy. And we used the structure of this parking as a geothermal exchanger. Once again. The project that was not our project, in fact, is again one of these projects that we arrive when they are already assigned to a builder with a price and everything. The project contemplated the reconstruction of the horizontal slabs of the building with concrete, a concrete that was exposed and very well finished, and that was molded with wood and was perfect in a mass, an enormous mass, more than 1 ton per square meter, because we are talking about 35 centimeters of concrete per square meter, and had no energy use. No? In fact, once again, as it is very normal here in Spain, there was an enormous pack of installations that provided this building with piping and with tubes to provide air. Again, air. No? So we said to the client, let's see, you can reduce almost by 75% the energy consumption. You can reduce the maintenance of the building almost by 60%, and you can spare every year almost 80,000 euros. And if you project this to 30 years lifespan of the building, you are going to spare a lot of money, and you are going to gain a lot of quality. Because if you are pumping air, cold air, into these people that are working here, they are going to become all in a difficult health situation. In fact, you can radiate over them with low temperature devices to obtain comfort and only renovate air in terms of air quality and CO2 and humidity. Well, bioclimatism was also possible in this building, even when the project didn't contemplate in any way any bioclimatic approach to the surroundings. This metallic cover that was completely remade had the possibility of circulating air through the chamber it has underneath, and through this we could preheat the air in winter, almost all the air of the building, because we have here a power of 80 kilowatts to only collecting the hot air that circulates under the roof. Then you see the system that integrates your thermal exchange in the parking was complemented. As a complement, we drilled some extra exchangers to complete the exchange that was needed to supply with energy this building. The building was completely balanced. Well, you see, completely balanced, not exactly. You see, in Madrid we need more cold than heat in office buildings, but in Madrid we have bioclimatical resources to complement the geothermal exchange to obtain this. And in this building we could cool the ground during the spring nights with this, because there's almost an amplitude of 20 degrees between day and night in spring in Madrid, and with this night cooling of the ground we have an extra capacity for cooling the building that we stored in the ground during spring and we used in July and August. So the building is balanced completely, and also through this mechanism of exchanging with air in seasons where the cool is available and using this cold during summer. And then we transformed, as I explained to you, all the slabs in absorption or transmission elements for low temperature heating and cooling. And with this system, this is the incorporation, this is what we call thermoactivation of slabs. We introduce piping in the slabs. This piping is designed not to radiate over users, it's used to transmit energy to concrete, and then concrete stores and transmits or absorbs energy from users. And this is the process of reconstruction of this rooftop mansards that they had in that building, no, with this internal system to be itself the structure, the device that cools and heats people. And this is the finished building. This is the placement of the final air renovation equipment that was much reduced and placed over the building in the highest edge. And this is the internal aspects of a building that has not piping and has not air impulsion grids and things like this. Only the small devices that are integrated to renovate air in terms of air quality, but air quality and temperature and heating and cooling are separated, because heating and cooling is in the ground. And the only thing that has to be done is changing this wooden, what was projected as a wooden floor, but to a stone floor that is better for the transmission of energy at low temperature. Well, and then can this be also drawn to industry? Of course, we are not only concerned with people, we are also concerned, like in this case, with plants. And this is a biotechnological factory in Portugal, where the product is obtained through the germination of a certain seed, that has a continuous process of 100 meters in 10 days, and then this process has to be fully controlled from the point of view of stress, thermal stress, temperature, humidity, and energy. So we designed a factory that was fully an element that integrated completely strategies regarding water, regarding air, and regarding energy, through air and through sun. And the building that's fully made in concrete, precast concrete, integrates the radiant elements that give energy at an absolutely equilibrated rate to the plants. The building is, in its geometry, its roof is designed to capture sun, to collect the water, and to introduce it in the industrial process, assuring not only a very high quality transmission and of energy and conditions to the plants, in this case the users, but also assuring security. In terms, if you lose supply energy in this building, it can work itself through its own means and using inertia during 3 days. Thus protecting the industrial process from accidents and this kind of problems. Well, we also work in the city. City is a major concern for us because buildings are placed over urban infrastructure. They work as an ecosystem of elements that interact, and where interactions are our main concern. And in city, not only the intelligent grid structures of the city are a possible solution, but also considering the integration of other grids of infrastructure, water, transport, public transport, tunnels. All of these things are under our cities. All of these things are full of energy that are conducted through pipes, through constructions, and all this is under our buildings that need energy. And most of this energy in urban infrastructure is wasted, it's never used. And we are working in the transmission of information between the points where energy is needed and the points where energy is produced and wasted, and the transfer of these resources under an intelligent grid of management, self-regulation, and information collection. And of these kind of projects, we published a guide 5 years ago. There was a divulgative guide that we published in Spain with the Energy Foundation of the community of the regional government of Madrid. And then we began working. We have been working in the 14 kilometers length of the tunnels that surround Madrid in Calle 30. And we have been extracting energy from these tunnels. The tunnels have energy from the cars that cross them, lots of energy. They have energy from the water that they are collecting because they interfere with the water underground systems, and they have energy also from geothermal interaction with ground. Using this energy, we have already provided with energy from the own installations of these tunnels, all the coolers that they have and the machines for air ventilation and all this, and we have reduced by 80% using the energy of the tunnel their requirements of energy for the cooling of the electrical systems of the tunnels. And now we are working in giving the energy. All this tunnel runs through an area that's full of public buildings, office buildings, and private residential buildings, and we are now studying the supply of energy recovered from the tunnels to the buildings in this area. This is the case of the Matadero de Madrid, a big cultural, theatrical and exhibition installation in an old building very similar to APOLONIO, to the Luis Velarde, the one we have already seen, and we are working in this. And we are working also in bigger contexts. In the city of Pamplona, northern Spain, we have made agreements with the managers of all the wastewater and water net to provide recovered energy from this net to hospitals and to the facilities, sportive facilities of some cities that are small cities that surround Pamplona. And we are also working in this project. This is the case. You have buildings that can store energy in their slabs, buildings that can store energy in the ground, but you can also connect them through appropriate exchangers to the wastewater net and collect energy that, if not, is wasted and thrown away without any use. No? Well, we go to Apolonio Morales. Okay, fine. Apolonio Morales, this building is a privileged building. It's in a very good area of Madrid. This area is like this, not casually. It's like this because it comes from the regulations, no? That come from the 50s and that are inspired by certain models of German residential areas in Europe. This is not very normal in Spain, but it was like this when this area was developed in the 50s. And so we have a very residential area with very good quality in terms of environment. Our neighbors have gardens and plants that give us for free. And then we have a low density and very good exposition to the wind. In Madrid, we have a climate that's very, very generous with sun. We have lots of sun to have. We have peak and low temperatures that give, as I have already explained to you, a big amplitude and that allow us to collect energy in summer for the winter and allow us to collect energy during the day for the night or during the night for the day. And this is an enormous opportunity because when there's change, there's opportunity of collection, of storage and of management. You know? And we are doing this in this building. We have all these previous possibilities through the environment. We have, of course, some previous conditions because we are rehabilitating an old building that was not well oriented. It was not southern oriented, it was eastern oriented. So we have to control the entrance of light and energy through devices that have to move and have to check the conditions to obtain a perfect balance. The building had some previous conditions that were terrible. The old building was completely closed with aluminium and glass. It had not any kind of interaction with the wind. It did not exchange properly light or energy, and it did not ventilate through the envelope of the building. No? So this is why it has enormous technical installations on the rooftop and enormous technical installations within the building. In the process of rehabilitation, we have, in a building that had formerly 700 square meters, we have recovered almost 120 square meters within the building that were occupied by former installations. No? The conditions of the users were very bad also. The radiation was getting into the building through the windows without any control, and radiation transformed in heat or in cold. In summer, in winter there was a big loss of energy through the facades. So the solution was that the building was full of fan coil installations, big, wide, and that occupied a lot of space that were pumping air, hot and cold air to the windows, and that were the place where energy was lost. And then users tried to control sun entrance because the conditions of lighting were very aggressive, and they recovered the inside of the building of papers and things to protect themselves, not obtaining any benefit of it, but lightning all the time, the artificial lighting of the building. This was the situation, a building that had many possibilities. Also some architectural problems, like the position of the former stair of the building that made people circulate diagonally in the inside, and as a result, the building was full of compartments and corridors that were not ventilated or naturally lighted. The structure of the building was good. The geometry of the structure was well conceived, and the possibility to overcharge a little more the structure with concrete was also possible. So we preserved 80% of the mass of the building, let's say all the structure, and we eliminated all the envelope, and we eliminated all the installations that in fact were a mean that was not effective in terms of exchange with the area. And then on this we detected at least 14 different strategies of behavior of the building, every one of them corresponding to a moment of change that gave opportunities regarding sun, light, energy, water, ventilation, and the use of the ground. And then on these strategies we implemented a control and information system that allowed our personnel and the users to interact with the building and implement all these 14 strategies, changing depending of the moments, and always oriented to the minimum consumption and the maximum quality. So the building adopted in the project this configuration, that's a configuration that responds directly to the need of pre-treatment of the air, control of the light and the energy, filtration of the radiation in the stairway, and recover an integrated way of behaving regarding the surroundings. We solved, of course, all the basic previous needs of remaking the envelope, eliminating every thermal breach, solving the integration of the devices that control light and sun, the carpentry, the windows that can act with the different temperatures, open and let air get in and out, the radiant barriers that allow the building to be completely glazed, not losing energy in winter nights through the glass, because this building charges itself in its mass with energy from the geothermal exchange system, and it can be used, this energy, through the glass if you don't have thermal barriers in certain moments of the day. We worked on the entrance of natural lighting, opening these skylights here and on top of the building, and also putting light through pipes. This light you have in these two devices over you is natural light in the ceiling. You have there two entrances of natural light that comes from the roof of the building to the heart of the building, where natural light is not so effective. So the building gets modified. We eliminate the envelope, we consolidate the structure, we change the position of the stairways, and finally we make a new envelope that responds exactly to the opportunities that we have here. And this, as a result, makes a reduction of the demand of this building of 60%. Only the envelope. Working through the envelope, taking things and controlling things. And then we have to cover these needs. We have to work with the air. We have to pre-treat the air. We have to assure that in this building, where energy of climate is separated completely from air, this is the reason why we have these small elements to renovate air, because heating is not in air, is in the concrete you are working on. And the pre-treatment system for air in winter consists in taking advantage of the sun to heat air directly before the injection of this air into the building. In summer, we cool air under the building and we introduce it to the building pre-cooled. So these pre-cooling and pre-heating devices that we have in the air system and the air separation from the climate system allows us to spare all the money and energy that was supposed to be waste in the renewable of air, warranting quality. Then we have several technical devices that manage all this after the envelope. We have the unit of air treatment that's on the rooftop, energy exchange. It can take air from different parts of the building, pre-treated, preheated, from the external area. We have this mechanical parking that's under the ground, and we are going to see in some minutes, that allows us to give to this building 14 parking places it didn't have. In fact, it had five cars here that couldn't maneuver, and this all was completely divided, it didn't have light, and this third of the building, this floor, was completely a low quality area, only devoted to people that wanted to make works of low value. When we have achieved the possibility of putting all the cars under the ground and recovering the quality of ambience, this is an area of the building that has the main value that all the building has. Then we have the systems that interact with windows and that open automatically windows when the conditions of temperature and humidity outside are good for putting the air into the building, to make free cooling during spring and summer nights. In Madrid, even in the month of June, we have an amplitude during day and night. We have 50